Now let's learn about the cached thread pool executor. In order to do so, we will write a code to demonstrate its functionality, and let's name the class as cached thread pool demo. We will have a task, so create a class for the same. Let's call this as task1. It will implement the runnable interface. Let's override the run method, and this class will have some sort of task ID. Let's call this as task ID. Initialize the same inside the constructor, and it can give some message, something like task, then task ID plus being executed by thread dot current thread dot get name. Then we will put this thread to sleep for, let's say, 500 milliseconds and surround this with try catch. Now let's write the main method, and we have executor service. Let's call this as service, and what we want is new cached thread pool. Let's keep it inside the try with resources. And one key thing to observe here is that there is no value that we are going to pass inside the new cached thread pool, unlike the fixed thread pool where we were passing the number of threads that we want to create up front. Why is it so? We will see in the next section. For now, let's run this thing probably for maybe 1000 tasks. So I less than 1000, I plus plus, and service dot call execute new task1 and give it a task ID of I. So let's execute this and see its output. Alright, so here is our output. You see, all the tasks are being executed by the threads that are getting created. So task 27 is being executed by the thread 28, task 41 is by thread 42, task 4 is by 5, and then task 1 by 2. So that's it for the code demonstration. Now let's understand how does it work internally. Now let's visualize and learn the internal workings of cached thread pool executor. In the case of cached thread pool, we don't have a fixed number of threads. So you see, in the code implementation, we did not provide any number to the method which was creating the new cached thread pool. The task queue here does not hold a number of tasks which we submit. The queue here is of a special type and it's called as a synchronous queue. The synchronous queue has space only for a single task. So every time you submit a new task, the cached thread pool holds the task in the synchronous queue and it searches for the threads which has been already created and they are not working actively on any task. If no such thread is available, the executor will create a new thread and add it to the thread pool, and this newly created thread starts to execute the task which has been submitted. Let's imagine a scenario where 10 threads are executing 10 tasks at a given point of time, and then 11th task comes in, and since we don't have a thread 11 to cater to this task, the thread pool will create the 11th thread to execute this new task. So in theory, the cached thread pool is capable of creating thousands and thousands of threads. You may wonder, where does this stop? If threads are getting created at such a rapid pace, so what is the upper limit? Well, there is a guardrail to keep the thread count in check. After some time, the threads are done executing the tasks and they are available to pick another task. And if they don't have any other task, they are killed, and this time of idleness is 60 seconds. So what I mean is, let's say there is a thread and it has not received any task to work upon, it will be terminated. So cached thread pool is pretty much auto-scaling in nature on the basis of task load it has. When there are new tasks to be executed, threads are added, and when there are less number of tasks to be executed, A few among the created threads could handle the task, so the other threads, the idle ones, are retired and killed. So that's how the cached thread pool executor works behind the scenes. So the basic takeaway from here is that the queue will contain only one task at a given point of time, that is your synchronous queue, and the maximum time for which a thread could be there in the thread pool without any work is 60 seconds. So now let's move ahead and learn about the final type of executor, which is the scheduled executor.